Polynomials, no matter how complicated they may look, just represent numbers. And like other numbers, you can add, subtract, multiply, and divide them. Sometimes you can even factor them, but sometimes you can't. It is important to recognize which polynomials can be factored and which can't. Let's look at the special case of binomials called the difference of squares. First, remember that binomials are polynomials that have two terms. A difference of squares is a binomial that consists of terms that are perfect squares. If you have one of the form a squared minus b squared, it factors to a plus b times a minus b. The key to factorability is that there is a difference of squares, not a sum, a difference. When you run across a binomial with perfect square terms, you have to make sure the terms have opposite signs. A squared minus b squared is factorable, as is negative a squared plus b squared. A squared plus b squared is not factorable. Negative a squared minus b squared is also not factorable. Now let's try this problem. Factor the expression 49x to the 14th minus 9y to the 20th. First, let's check if that binomial is a difference of squares. The signs of the terms are opposites, so we have a candidate for a difference of squares. Now all that we have to check is that the terms are perfect squares. The coefficients of 49 and 9 are perfect squares. Since the exponents on the variables are even, this means we have a difference of squares. 49x to the 14th can be rewritten as 7x to the 7th quantity squared, and 9y to the 20th can be rewritten as 3y to the 10th quantity squared. This gives us 7x to the 7th quantity squared minus 3y to the 10th quantity squared, which can be factored to 7x to the 7th minus 3y to the 10th times 7x to the 7th plus 3y to the 10th, or answer choice C.